Hello.
Hi. Okay. We're still missing a few, so let's just wait a couple of minutes. What should be there? That's the type of questions I'll ask.
Okay. So for what was due today, like with the packet switching stuff, we only had to run a couple simulations and it wasn't like the same sort of nature as the previous ones where we had to collect a lot of data. So
right.
We have to do that for next week or
you should have you should have it done already, right?
Yeah, it's done already, but
okay.
We weren't supposed to graph anything, right?
No, just to get the results. Actually, we could extend on that. Okay, maybe we could. Maybe we could discuss that.
Yeah. I was having issue with it when I was running, and my mobile extreme was keep crushing. So I don't know. Like when I was trying to get the results.
Yeah.
Yeah, like my whole computer like got froze, and then I had to restart my whole computer to get it. I don't know why.
I don't know why that happens with you.
I asked like some other people. They said they had like similar issues too. Like some people didn't get the graph and all that. So.
Right, but some, I think some already got it. So I think there was a specific station that they used. Anyone who will go over. Anyone who finished packet switching can put their work on the share their work here.
Sure, I could do it. Give me 1 second to get a mobile terminal running.
Okay, so yeah, let us see. Could you run it and let us see what you have?
Okay, 1015. That should.
Okay.
Oh, sorry. Here we go. I believe this is for the second one.
This is, it seems it's packet switching one, right?
Oh, let me see. Because I think the difference was the values of okay, if this is packet switching one, I could just show this one and then just change what the let's see. Okay, you want to see packet switching too as well?
Yeah.
Okay, let me just change the
Whoever is talking in the background, could you mute yourself?
okay.
I don't think this is what you're supposed to get. Could you show me the exact the tutorial? Let's look at the graphs you should get.
Sure.
Cool.
Tutorial. This is one. This is two.
Yeah, after one, let me see. Go. Yeah, the results. Yeah, what you should be getting.
Okay.
You have two two values. Yeah, it T and D. Okay.
Okay. Yeah. So SNAT. Yeah, I should have two. I had it last time. Let me see.
So yeah, that's the delay.
That's one of them. Let me see.
One for subnet 1 and the next is for subnet 2. So you have to have dual subnets, yeah. And then and then check the delay. So what is, yeah.
Yeah, it's checked. I had it last time. Hold on. Maybe I'm
That's
forgetting.
fine.
Deleted the. Two simulations. Should be running two. I think it's only running one. That's why. Let's see. It's here. Let's check this again. Okay. I think it's around here. Use multiple values. Okay, that's why. That's why. Okay. 8. And then as well as 80. Apply.
Whoever is sharing the room with somebody and they're talking in the background,
Yeah, that's me. Sorry. I'll mute it.
that's you. So could you ask them to, are you in a coffee shop or something? Or
I'm in the library. Oh, there we go.
okay. Yeah. And let us, let's look at the utilization.
Okay.
Yeah, okay. All right. So one thing that you guys could do here is, do you see how the utilization is just about on one network, it's almost nothing, 0.1% or 0.18 maybe. And on the other network, it's about 1.3. You see that?
Yeah. Yeah, I see that right here.
Okay. So similar to what we did before, we could change the inter-arrival times, decrease it basically, so that we could get higher utilizations. Because obviously this here is not, it's kind of a trivial scenario, right? If the network is operating at 1%, who cares? So we would be interested in looking at the performance at 90% utilization, 95, 99, and so on. So you could, again, do the same thing that we did before, and you will get values for the delay. And you could, again, plot the utilization or plot the delay versus the utilization. And you should be getting, again, similar to graph to what we had before.
Okay.
Right, everyone? Do you all hear me?
Yes.
Okay. So other than that, what was the what was the server that worked for you?
This was running server 74.
And the rest of the class?
I use 75.
Okay, and it worked fine?
Yes.
Okay, could we have a look at your results?
Yes.
All right.
Louis, do you mind if I take over?
I don't know. I got you.
Okay. Hold on. Let me pull it up. Okay. Can you see my screen?
Yeah.
Well, actually, here I just ran it, so here's the results.
Right. Right. Okay.
For the
right. Yeah. And the utilization. Yeah. So again, it's very small. All right. So anybody else did the simulation? Did packet switching one? I mean, one and two actually. Okay. I'll just poll you one by one. Hold on. Douglas Shuang.
Yes, Professor, I got it to run. I have screenshots for you if I can share those.
Yeah, but you should be able to run the simulation, huh? Why can't you run it?
I was just gonna show the screenshots, but if you want me to run it, I'll run it. Just give me a second. Okay. This is also on server 74. Um, I'm sharing the wrong thing. Hold on. Um, okay.
Okay. And the utilization.
Hold on.
What happened?
I'm just opening it now.
right, I have to go to someone else.
Yeah, can you go to someone else while I get this to?
Radley? Ah, okay. No, next time we have to look at it. You have to, because next time is the midterm actually. So you have to have all your data and be ready to run simulations. You could go anywhere. It doesn't have to be the lab. All right. Silva?
Yes, Professor.
You have the
Yeah.
work for packet switching?
Um, can you see it?
Yeah.
I just showed the utilization.
Why your utilization is 8%? Anyways, you probably used a different inter-arrival time. What did you, let me see the delay. Point 3. And you have only one set.
No, I ran multiple scenarios. The thing is, it's not showing. I think someone else got on one of the servers I was on, so it kicked me out of that one. So I'm redoing it. I wasn't redoing it, but I'm just, this is the one that I'm
Okay.
going to.
Okay. Hoi Wu.
Yeah, I'm gonna share the screen. Wait, is it showing up? Okay. You see it, Professor?
Yeah. Yeah. Okay. Lewis, I just saw your stuff, Lewis. MD Rahman.
Yeah, Professor, I was telling you about that, how my computer was crashing. But
Okay.
also last class, I couldn't show you the packet loss because my graph is there. So you want to see it right now?
I'll probably see it next week or.
I mean, it's ready. I'm just gonna show you the data and stuff.
Okay.
Just give me a second. I'll quickly show you. Yeah, so that's the packet loss, and I got the graph and everything. So, and I also put the packet generator wasn't there, so I put them.
This is not correct, by the way.
It's not.
No, your y-axis has to be log scale, and you stopped. Yeah.
Okay.
So this is linear. It cannot be linear.
Okay.
Because you see what's happening. All the points are all lying on the top of each other towards the bottom. So this is still not correct. Okay. Nora Silva.
Professor, I'm sorry. They just kicked me out of the server. Can you give me 1 second?
Sure. Hassan, Rahat. Doesn't seem he's there. Sujad, Tafadar.
Hi, Professor.
Yeah.
Give me 1 second. Can you see my screen? Here's my utilization for transmitting. And
Okay.
here's my utilization for receiving. And here is my UTE delay.
Okay. Hussein, thoughts? Do you hear me? He's not there. Okay,
Professor, I'd like to show my result.
hold on.
Okay.
Winham,
Hi, Professor. I'm not sure now.
yeah, go ahead.
All right, can you see it?
Yeah.
So this is utilization, and then here's the delay.
Okay. Yunus, Bao,
Yes, yes, Professor. I just tried to run this, but I have some problem with I use the computer with number 1. Everything is okay, but the last part I tried many times, and it shows me errors, some 4 kind of errors. So at this time I cannot.
so
hear
you
it.
can ask your colleagues which computers work, right? And use those computers.
Okay.
Shuang, Douglas,
All right. Give me a second. I'm sharing it right now. Okay. This was the delay.
yeah, okay. So all right, fine. So as I said, what you could do is run different inter-arrival times, basically decrease them because you want to go into the direction of high utilization. So you're going to decrease the inter-arrival time and keep decreasing them as in the same manner as you did before, and get the numbers, get the values for the delay, and then you plot the graph as usual. Okay, everyone?
So for that,
Sure, yes.
we're plotting the delay versus the utilization. So,
Right.
And in this case for packet switching 2, there's two subnets, right? Or two packets, or not two packets,
Two subnets.
Yeah, 2 subnets. So
Right.
do you want it for both of them, or as separate graphs, or just like one?
It doesn't matter. Well, whatever. It doesn't matter. The whole point is to show the trend. That's all.
Okay. And do these have the same? Because obviously we're setting the inter-arrival time. Those are just constants that we have to set, so we can add more constants. But this follows the same equations from the previous queuing, right?
Yeah, but here there isn't really much equations. I mean, you're plotting the inter-arrival time. You're changing the inter-arrival time. That's an independent variable that you just that you input there, and then you have utilization. Then you have average utilization, and you have average ET delay, right?
Okay, thank you.
So basically, you will have a table, inter-arrival time at one entry. Next to it would be delay. Next to it would be utilization. Yes, somebody asked.
Yes, Professor, I have it ready.
All right, go ahead.
Yeah. Right here, the utilization.
Right.
And the ET.
Yeah. And of course, you all know how to go back to, So for example, here, you all read the average that towards 40 minutes or 50 minutes, that should be the value that you use.
Yeah.
Okay, so please, everyone, be ready for next time. I might not be able to finish everyone. I mean, to be done with all of you next week. So if not, then we'll continue the week after. Yes, go ahead.
Okay. So for the graph that you want next week as well.
Right.
I understand there are different source inter-arrival times. Like
Sure.
you saw when I was putting it was a 40, 4, 80, and 8. Do you want to see all of those?
So here you don't. I mean, the way you want to do it, it's up to you. But
okay,
I want you to use multiple inter-arrival times.
Mm-hmm.
And each time you put a value, and as I said before, you need to go into the smaller values into that direction. Okay. So you're not gonna go 4 and 40 or 8 and 8. You want to go 3, 2, 1.5.1, etc., etc. That's the direction where you're gonna get higher utilization.
Okay.
So how you want to do that, run each one, it's up to you. You run a bunch of them, 4, 5 together, whatever it is. It's up to you. Okay. What else? Yeah, so make sure your data is complete. Especially in packet loss, you have to know the number of weeks that you're gonna run the simulations. You have to know your packets generated, your packet loss, and therefore the packet in the buffer. I mean the queue, and therefore you can get the packet loss, etc. In addition, of course, to finishing this part here. What else? Yeah, that's it. After that, after we're done with that, then you're gonna do the project, which is very similar to the small internet working that we started with, but it's just different parameters, different input parameters, different source. So we'll talk about that when the time comes. Yeah, probably in maybe we'll see. Maybe we can discuss this next week or the week after. But you have a file already that explains the project. Did you all download these files from Blackboards? Any one of you downloaded the files that I uploaded in the Blackboard? Hello?
I think we've all seen the files, Professor.
Okay, so do you have the file that that talks about the project?
The cloud exercise?
Right. Can you display it?
1 second.
Okay, so it starts here with something called cloud modeling exercise. That's just an example amongst the examples that that are in OpNet. You could just run it and look at the results. Yeah, and then it tells you here what kind, it gives you the results that you're going to get. Here, here it tells you you could do changes, edit attributes in the application and the profile config. So because that's basically what you are going to, that's what we're going to do in the project. All right, move down. Hold on. Yeah, so how the profile and the application is defined at the node. Okay, move down. So the voice configuration example here is not really, if you want to do it, fine. If not, it's an optional thing. So you could just skip this. Move on. Yeah, move on. You will do this in the exercise in the project. Hold on. Yeah, go up. How to choose the results. All right, go down. Keep going. So this tells you the results and how to choose them, how to display results. There's so many results that you could display. Okay, keep going. And this is really the beginning of the project right here at this point. So it's, as you can see here in the graph, there is a router in the middle and it's connected to two Ethernet or two networks. Each network is an Ethernet switch, as you can see, and connected to a number of workstations. I have here 3 workstations on each side. If you want to do 2 workstations, that's fine. That's fine. If you want to do more than 3 on each side, that's also fine. And of course, you have the 2 classical nodes, the configuration and the application, where your traffic will be generated. Now, there is an example here. Keep going. for a specific set of, do you see here? There is a specific, wait. There is a specific combination, basically. So you see here a profile and the application. So there is a choice here that was done. And profile called the engineer, and then researcher, and then e-commerce, sales, multimedia. And under each profile, there is a choice of a set of applications. And then at each workstation, this specific set of profiles was chosen. You see that? And based upon that, if you run this, you will get some result. And that result, as you can see here, is about 45% utilization, and then the corresponding delay with that. Okay, so what I suggest to do, keep going. That's it. Is there anything else? That's it, right? Is that the end of it? Yeah, okay. So what I suggest to do, I'll take the screen now. So this is basically what you have. And some sources. Like I said, the minimum here would be 2. And if you want to do more than 3, it's up to you, S sub n, hosts or sources. And then here, this is 10 meg, 10 meg, 10 meg. And the reason for 10 meg is just that we could run the simulation and get results without running into issues like memory problems and the simulator gets frozen and all that. Of course, these are not really realistic numbers at all, but this is what we can do given the limitations of the processing powers of the computers we have. So usually this should be 1 gig at least, this should be 10 gig, or this should be 10 gig, and even here 100 gig. But anyways, so it is what it is. We're gonna work with this. So you could define, as you see in the example, at each station, you could define a set of profiles, one profile or multiple profiles, as you've seen. And each profile is associated with it a number of applications. Now, the whole point is that we want to show that we want to understand how the network operates, very simple network, under different types of applications, but not necessarily different profiles. So at least as a starting point, I recommend that you define only one profile, just one profile. And that profile, you can define it for all the stations. And in that profile, you could have multiple applications. So you have to have at least one voice, one video, and then a couple of data applications. Data meaning something like HTTP. You could have file transfer. You could have or database here. Something like that. So this would be a good set of applications. Now, you will see predetermined or pre-specified profiles. One, as we said before, you will see there's something called engineer, which has certain applications associated with it. You will have another one called sales, another one called multimedia, and so on. I, again, suggest you define your own profile. Anything. Profile X, for example. And under that profile, put the applications that you want. So we need a set of applications like this, couple of data and one voice and one video. There is also an application called streaming. And I think you are all familiar with this because you ran across this with small internet working. You want to add streaming as well, that's fine. And basically, what you are going to do is the same thing that what we have been doing, is change inter-arrival times here. And each time you choose a set of inter-arrival time, you're going to have a delay. So you're going to plot something called Ethernet delay, which you will see in the global statistics or under the global statistics. And again, you will have the same graph, something like this. Utilization versus delay. Now, there is a lot of traffic or a lot of results that you could plot. So, for example, you could plot or have amongst the result. Of course, you can have the utilization. And by utilization, which utilization I'm talking about? I'm talking about the utilization of this link or that link. And traffic, of course, is going both ways, this way and that way, like this. So again, pick up just one direction. So you could pick up this direction, for example. That would be fine. And plot the delay versus the utilization of this link or of that link. Or if you want to average, that's also fine. Now, you could also look at the traffic in bits per second or packets per second on all these links. And I suggest you do that. In addition to plotting the utilization, look at the traffic on the link. So why? Because I want you, as you change the inter-arrival time, as you're generating traffic on the network, be careful that so if this here is 10 meg, as we said, you cannot have a situation where you are generating here. Let us say you are generating here 9 meg and you're generating here 9 meg. So you cannot have this. Any result you're going to get out of this is going to be just false, because you are basically putting 18 meg over a 10 meg link, which is, of course, wrong. Are you following me?
Yes.
Are you with? So basically, pay attention to situations like that. You cannot have more than 10 meg here, actually 9.9. So, so this means that sometimes this is like, again, an ad hoc process. So because you do not really know which set of inter-arrival times will give you the right utilization that you want. You do not know that beforehand. But once you test a couple of values, then you will be able to understand how it works. Obviously, there is an infinite set of choices. For example, if I have here let us say 4 applications: video, voice, FTP, and I don't know, maybe email. And then, of course, you could have very little video, very little voice, a lot of FTP, a lot of email, and this will give you this set of choices will give you a utilization of, let's say, 50%. Now, you could make your video, make the video traffic high and nothing here, zeros, and you'll still get 50% out of some video traffic. You see where I'm going with this? So when we say 50% utilization or 60% utilization, it means I really have infinite choices here. So what you should do is avoid situations where the video or the voice or the video and voice dominates the traffic so that you have 90